Hi all, you're going to need a calculator to complete today's lesson, so please make sure that you do have one. We're going to be on page 12 of the module for Booklet 2. Today we're going to be looking at quad applications. So on page 12 you have this equation. There are some typos here, so let me first address those. This should be, let me just rewrite this. H of t equals 64t minus 16t squared. T is going to be the time in seconds, H is going to be the height in feet. So T is time in seconds, H is height in feet. So a couple things. Find the maximum height attained by the rocket. So you're going to need to go to your calculators and you're going to need to plug this function in. Obviously, I do not have an Inspire here, so you know how to graph on the Inspire. You're going to go to the Inspire and type in 64x. You're not going to be able to type T in there. Minus 16x squared. Again, that's on new document. You're not saving. You're going to the new screen. You're going to hit enter and you'll get a graph. I don't know what you'll be able to see, if anything, on the graph. So I'm going to teach you a trick of how you're going to utilize your window. So you got to be really mindful here that this is that A value, negative 16. The B value is 64. So let me come back to the lesson here. So to figure out where to center your window, you're going to do the opposite of B divided by 2 times A. That's going to be where you're going to want to center the window. So here the opposite of B is negative 64 divided by 2 times A, which is negative 16. This ends up equaling a positive 2. Positive 2. So that's where I'm going to want to center my window. So if I go back to my calculator, so on your calculators, you're going to want to go to your table. You're going to want to get 2 in the center. And what you're going to see, similar to what we saw in vertex form, is you're going to see some matches here. Yours is only going to show from 0 to 4, but you should see the 0s matching, the 48s matching, and the 2 and the 64 not matching. So what that tells us is, let me delete this for a moment. Escape and scroll down. Okay. We just got a vertex of 2, 64. We've done some work with vertex before. So remember, X is the time in seconds, Y is the height in feet. So the maximum height is 64 feet. Pardon my handwriting here. 64 feet. How many seconds did it take to reach the max height? It took 2 seconds to reach the max height. What time did the rocket hit the ground? So we're looking for an x-intercept. So if we go back here, I'm just looking, not the original 0, because that's when it took off. The y-intercept was 0. It was after 4 seconds. I can see here I have a height of 0. If the height's 0, it's on the ground. So after 4 seconds, the rocket hit the ground. So all we're doing once we get the maximum, what this is saying, we're looking at that point, which was the vertex. H is the maximum height, and T was how long it took to get there. So for us, the maximum height was the 64. How long it took to get there was the 2 seconds. When it hits the ground, that's when Y is 0. So you're looking for the 1x intercept. We're not going to go into the negatives, and we don't care about 0. 0, 0, that's the origin. In some cases, that'll be where the rocket was launched from, as in this case. Okay, so that's the first question. Let's move on to page 13. Okay, a couple things here. A ball is thrown upward from the top of a cliff with an initial velocity of 96 feet per second. The height, h of t, of the ball after t seconds. So a couple things to be mindful here. We have height is a function of time. So again, x, y, we have height and time. This is going to be time. This is going to be height. And these should all be t's here, not x's. These should be t's. Okay, I know that's kind of hard to see, so let me just erase that, but that's what those should be. Okay, so they want us to graph the function below. So what we're going to do is we are going to plug this function into the calculator. Couple things. This is going to be our y-intercept. We know that from previous lessons. Since a is negative, this is going to be concave down or opening down. So the parabola is going to do something like this. All right, we're going to have to get a little more specific, but I just wanted to provide you those details. So let me erase this and we'll get right to it. All right. Okay, so we're going to go to the calculator. We're going to type in this function. So you're going to have to go back, clear out what you have, type in your negative 16x, negative 16x squared plus 32x plus 128 plus 32x plus 128. Okay, hit graph. Depending on your window, who knows what you're going to see. This is concave down, the vertex system, or up here. It goes up, comes back down. We're going to kind of hone in on that in a minute. So, like I did in the previous example, if you want to know where to center your table, you take the opposite of b. So we're going to go the opposite of b, negative 32, divided by 2 times a, 2 times negative 16, which is going to be, in this case, positive 1. So we can center our table at positive 1. That'll give us our vertex. And I can see right here, if 1's in the center, again, we're not going to go into the negatives. We're not going back in time. We're only going to be starting at 0. But I can get a sense of what I'm going to have to graph here. All right. So if I come back here. Oh, excuse me. All right. So let me delete this. All right. So for our graph, we have x and y, or the time and the height, whatever you want to think of it as. So at a time of 0, this is the y-intercept. The height was 128. I go back to my calculator. At a time of 1, the height was 144. Time of 2, we're back to 128. At a time of 3 seconds, we're at 80. And a time of 4 seconds, the height was 0. All right, so what I'm going to need to do is I'm going to need to label some axes here. This is going to be the time in seconds. This is going to be the height in feet. I'm not going to be able to go up by ones here. So if I go up by tens, I think that would work. 10, 20, 30, 40, 50. So this would be 50, 60, 70, 80, 90, 100. 10, 20, 30, all right, this is 150. So 50, 150 time. I can spread this out a little bit. 1, 2, 3, 4. It's kind of hard to write on here, so I'm just going to put a couple of these on here. Okay, so at 0, the height was approximately 128. So 10, 20, 30, 128 would be about here. At a time of 1 second, the height was 144, so about here. 2 seconds, we were back at 128. 3 seconds, we had a height of 80. That's 100, so 90, 80. And at 4 seconds, we're back at the ground. So the graph is going to be this nice smooth curve through these points. It's kind of hard to do this on here, so bear with me. It should be easier on your papers. Okay, so we're seeing part of the parabola. Okay, so it's going up to its vertex or its turning point, its peak, its max, and then back. down where it's hitting the ground here at 4, 0. Okay, so what is the maximum height of the ball and when does it reach its max? Excuse me. This is the vertex here, 2, 128. So I'm going to delete this and scroll down. So here we had the vertex was 2, 128. The x was time, the y was height. So the maximum height of the ball is 128. Oh, no, totally wrong. Totally wrong. Delete. I'm sorry. The vertex was not 228. The vertex was 1, 144. And if I go back to the table just to show you, you can see that's the max. And then the numbers pair up after that. So my mistake. The vertex is 1, 144. So again, time in seconds, height in feet. So the maximum height is 144 feet, which is reached after 1 second in the air. That's how long it takes to reach the maximum height. How long will the ball be in the air before it hits the ground? As we mentioned in the previous question, just looking for 0 in the y column. We're not going into the negatives. As we talked about, every quadratic will have 2 solutions, but we're not talking -2 seconds. So it's going to be 4 seconds. So 4 seconds. What is the y-intercept? We looked at that before. That is just going back to your equation. It's this number here without any x's. So your y-intercept is 128, or 0, 128. So this is time, this is height. So at 0 seconds, ball is 128 feet above the ground. Okay, so that's what it means in the context of the question. The y-intercept is 128, and that's what it means in the context of the question. Okay. So I am going to delete this. All right, so now what I'm going to suggest that you do is you go ahead and pause the video and try and work through page 14 on your own. In the next video, I am going to go through the answer key so that you can understand how I did page 14.